So Fermat had a method of finding the area underneath the curve y equals x to the n power, and he did it by splitting it up into rectangles, but unlike before, these rectangles have different widths, and I'm going to show you how this applies to a specific example. Here's y equals x squared, and this is length of 3. And we pick a value, something called r, and I'm going to make r 2/3. What this is going to mean is that my answer is not going to be exactly right, but the idea is that the first rectangle, you know what, I'm going to make this 3 a little bit bigger. So this is distorted now. So this is 9 up here. So if r is 2/3, the first rectangle is going to have its right hand corner there. But if I multiply 3 times 2/3, I get 2. And that's going to be my first rectangle. And that rectangle has an area of, the base is 1 and the height is 9, so it's 9. Now is where this 3 is the length of the whole line segment. Now, to get the next endpoint for the next rectangle is going to be skinnier. If you multiply 2 times 2/3, you're going to get 4/3 is the location of this point, which means the base is going to be 2 minus 4/3, which is just 2/3. Now the height's going to be 2 squared, because it's on this y equals x squared parabola. So the area of the second guy is going to be, the base is 2/3, the height is 4, it becomes 8/3. If I multiply 4/3 by 2/3, I get 8/9. And that's my next rectangle. Now 4/3 minus 8/3 is going to be the width of it. 4/3 minus 8/9, which is 12/3 minus 8/9. 12/9, which is 4/9. And the height is going to be 4/3 squared, because 4/3 is the x-coordinate, so it's 16/9. And when you put these together, the third rectangle has an area of 64/81. Now if I keep doing this, I get more and more rectangles. Eventually I get an infinite number of rectangles. And the sum of all those rectangles will be 9 plus 8/3 plus 64/81. And at least these three terms do have a geometric series. It's 8/27 times the one before, and just to check, you multiply 8/27 times 9, and you do get 8/3. So it's a over 1 minus, a is 9 in this case, 1 minus r, so 8/27, which is 9/19/27, which is 9 times 27/19, which is 243/19, which is about 12 and 15/19. So that would be the combined area of all these rectangles, which is bigger than the curve itself. In order to get a more accurate answer, I would need r to be much closer to 1. The closer r is to 1, the better my answer is. But I can't just make r equal to 1, because then if my first rectangle's corner was a 3, the second point would also be a 3. I'm not going to make any progress. So what I'm going to do is just leave r as r. So this makes this point here is 3r, and this point here, x-coordinate is 3r squared, and this one's going to be 3r cubed. So the width of this rectangle now is 3 minus 3r, whatever r is. And the height is 3, so it's 3 squared. The second rectangle's width is 3r minus 3r squared, but its height, if this point is 3r, is parentheses 3r squared. And the third rectangle is 3r squared minus 3r cubed. That's this little distance. And the height is going to be 3r squared. Well, when you put these things all together, first of all, you can factor out a 3 from here and give that 3 to the 3 squared, so I get 3 to the third times 1 minus r. The second one, I could factor out a 3r and give it to this 3r squared, so I get 3r cubed times 1 minus r. And the third one, I could factor out a 3r squared and give it to this other 3r squared. I have two of them, so it's 3r squared cubed times 1 minus r plus dot dot dot. This 3r parentheses squared is 3 cubed r cubed, and this 3r squared cubed is 3 cubed r to the 6. So if I factor out a 3 cubed and a 1 minus r, inside I'm left with 1 plus r cubed plus r to the 6 plus r to the 9th. Now, not so obvious from looking at it, but this thing here is a geometric series. Each term is the term before times r cubed. So that means that the sum of 1 plus r cubed plus r to the 6 plus dot 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 is a over 1 minus whatever the common ratio, which is 1 over 1 minus r cubed. Funny, r, in this case, r cubed is like the r value. So I have times 1 over 1 minus r cubed. Now we learned also that you can factor 1 minus r cubed into 1 minus r times 1 plus r squared. And in general, for instance, 1 minus r to the 5th power could be factored into 1 minus r times 1 plus r squared plus r to the 3rd plus r to the 4th. So that's like a thing you can do. We can cancel out the 1 minus r's, and finally we can let r equal 1 like we wanted to from the beginning, and we get 3 to the 3rd over 1 plus 1 plus 1 is 9, which is the exact answer.